Let's first read the example to see what it asks for. This company produces these products. Each type of clothing requires great thread to acquire appropriate type of machinery. The machinery needed to manufacture each type of clothing must be rented at the weekly rate shown in this picture, in this table. This table lists the amount of cloth, labor required per unit of clothing, as well as the selling price, and the unit available cost for each type of clothing. There are 4,000 labor hours, square yard of cloth available in a given week. So first we have to identify our variable. Profit equals revenue minus cost. The objective is to develop a linear model with binary variables that can be used to maximize the company's profit, accounting for fixed costs and staying within the resources available. So the objective is here, we want to maximize the profit. Revenue is kind of constant, and we want to maximize profit by minimizing the cost. So first we have to identify the main elements of cost. First element is the machinery. And probably the raw material for clothes. Raw material and also labor. We want to use the number of machines as our decision variable to be able to stay within our limits and also to maximize our profit. And constraints would production must be less than the capacity. Must be less than or equal the capacity. And our decision variable is a kind of binary variable. We want to use integer programming, 1 or 0, use or not use, to be able to maximize our profit. Okay. So here in this model, these are the input variables, the labor hours needed to produce shirt and other clothing per unit, selling price, which is the revenue, variable cost, and fixed cost. Our decision variables are these two variables: purchase equipment and units produced. And this unit produced must be less than or equal to the upper limit of the capacity of this manufacturing company. Okay. So the other constraint is that resources used must be less than the available resources. These are the two constraints. So I'm going to name these ranges. First, we need to highlight this range and then go to formula, create from selection. The top is going to be the name of the variable, available, create from selection. Next variable, units produced, decision variable. This is the second decision variable, purchase equipment, and logical upper limit. And profit is the objective, which has to be maximized. Okay. So now we have defined name for these ranges. Now we have to connect these variables, all these variables, to the decision variables. Okay. I'm going to put some trial values for this decision variable. This purchase equipment must be binary, 1 or 0. I'm going to put just 0, 0, 0, 0 trial values. The same for the second decision variable, 1, 1. Excel will change these values later. And logical upper limit. Now we have to calculate it. The upper limit is going to be B14, the purchase equipment, times minimum of the labor hours divided by labor hours per unit, and cloth divided by unit. B equals B14 times minimum of the D22. This is constant, so I'm going to use this dollar sign, D22 divided by, or labor hours divided by labor hours per unit. B5, and number of clothes, available clothes, D23, 23 divided by clothes per unit, B6. And then I'm going to copy it across. Resources used for labor hours, use sum product of units produced and labor hours, B5 through F5. This is going to be the labor hours. Cloth is going to be the sum product of units produced and number of clothes, B6 through F6. Revenue, it equals again sum product of the units produced by the selling price. And B8 through F8. For variable cost, again, is sum product of the units produced and variable cost, B9 through F9. B9 through F9. For fixed costs, for equipment, we need to use this decision variable, purchase equipment, equals sum product of purchase equipment and fixed cost for equipment, B10 through F10. And the profit is going to be revenue minus cost, B26 minus variable cost minus fixed cost, B26 minus B27 minus B28. Let's look at our variables. We have available logical operating profit, purchase price, resource use, units price, and profit. These are variables. Okay, now we have connected these variables with the decision variables. Now we can go to data and develop our model. The objective is going to be profit. We want to maximize this profit. Our decision variables are purchase equipment, purchase underline equipment, and second decision variable is the units produced, purchase equipment and units produced. Now we have to add our constraints. The first constraint is that the purchase equipment must be binary, whether it is either 1 or 0, whether we buy or not buy, or purchase underline equipment must be binary. And the second constraint is that resources used must be less than the available resources. Resources underline used. Make sure resources used must be less than or equal to the available at call reference was empty resource misspelled this one at. And the second constraint is that unit produced must be less than or equal to the logical upper limit. Units underline produced must be less than or equal logical underline upper limit at I think everything is right. And this is for non-negativity constraint, and we select simplex linear programming. Let's see what we get. Here's the result. That's how this company can maximize its profit through minimizing its cost by purchasing some equipments and minimizing its variable and fixed cost. Here's an example of integer programming. We buy or not buy. We not purchase this equipment. For sure, we purchase equipment. And for jacket, this way we can reach maximum profit of $54,000. Is there any questions? I hope everything is clear in this model. Yeah, that's all for today.